my name's actually not George Pullen. George Pullen is he's one of my colleagues at work at University of New Hampshire School of Law. So if I say anything bad, just say it's his fault. Or anything you don't agree, it's George's fault because I can't change my name. George is actually a space economist, which is really funny because most people don't think space have economists, but they really do. And so I just want to give everyone a little bit of context. I'm on the road at the moment. I'm traveling, helping with some of the transition team stuff here in Washington, D.C. And so this is why I'm in a hotel room today. But I want to give an example because I love playing chess. And so there's probably a lot of people out there who play chess. And if you have a question while I'm talking, feel free to drop it in the chat. I'm monitoring that as well. So if I taught everyone there how to make chess pieces, pawns, rooks, knights, queens, bishops, the board, right? Everyone on this call, everyone listening to this, everyone watching this, you guys would know how to make chess pieces. And that'd be really cool, but you guys wouldn't be chess masters, right? So I could show you how to make a chess piece, but then I have to actually teach you how to play the game. And so I want to keep this in mind because when I talk about blockchain or any technology, if you have a piece of paper, I want you to write down these 4 things. Create 4 little boxes, 1 box, 1 box, 1 box, 1 box, and then put tech in the first box, economics in the box right below that, then philosophy in the next box, and then regulations on that 4th box. Because so many people want to learn the technical aspects of blockchain, distributed ledger technology, of aerospace engineering, and that's super cool. That's sort of like teaching you guys how to make chess pieces. You don't actually understand the game. You might not understand how they all come together. You might not understand the strategy. And so I tell this to you to establish some context, because as you go out to develop your technical skills, hands down, the other thing you need to do is learn how to be an effective communicator. And I see so many technologists who don't know how to communicate their mission, their vision, their values, or their dreams. Because if you're working in the blockchain space, or the AI, the neural net learning, the computer vision, you name a buzzword, right? I work in the space economy. You've got to be able to explain what your mission, what your vision, what your values, and what your dream are. And it's not a technical explanation because you're going to sell this to people. We're going to talk about that a little bit later when we talk about crowdfunding. And I suck at telling my story. I'm trying to get a little bit better at it. And so as I struggle with telling my story, I'm also sharing this with you because communication, it remains the most elusive key, the most elusive skill set for all technology and all particularly emerging technology fields. So keep that in mind. Because again, everyone can learn how to make a chess piece, but that doesn't necessarily mean you know how to play the game. Same thing when we talk about blockchain, emerging technology, and of course, this thing called the space economy. So now that I've said that, I'm going to take a couple step backs and I'm going to tell you about the space economy because it's related to blockchain intimately, very much so. So I'm going to just hit you with the spoiler alert. Oh, I think I see some questions here over on are those questions for me in the mailbox? Oh, okay. Nope, that's not for me. So what I want to tell you about blockchain and the space economy, I recently wrote a book with this guy named George Pullen. And so if you're already familiar with blockchain, I'm not going to beat that to death. Just think you're in space, you're around the Earth, around the moon maybe. So you've got satellites in space. So when you're thinking blockchain and the space economy, your satellites, those are your nodes. That's it. You've got a network of satellites navigating around the globe, and the satellites become your nodes. That's literally it. That's the entirety of blockchain and the space economy. The question is, what do these satellites do as nodes? What data are you managing? What records of data are you managing? Right now, the majority of space data, space generates terabytes of data every second. 90-something%, 98% of that data never actually makes it back down to Earth. It just gets discarded because the satellites only have so much capacity. They can only send so much data down, and the rest of the data, it just gets thrown away. There's not actually a cloud for satellites yet, but there will be. So when we talk about blockchain and the space economy, we're saying you've got all these satellites. Those are your nodes. Now, what business do you want to do on those nodes, aka satellites? So blockchain is established. It's a really great way of managing records of data. It's a really great way of encrypting records of data. Blockchain is so good at encrypting records of data that you can display those records publicly. That is literally what the Bitcoin blockchain does. It's like, oh, Bitcoin, it's the public display of records. That's it. And so that's blockchain. So when you go into space, do you want to encrypt your data so well that you can either share it publicly from the satellites, like weather data, for instance, are asteroids that are coming near the Earth, or do you want to run it on a permission blockchain because you're doing some type of business? So that's where blockchain and the space economy comes together. So of course you're asking, Samson, that's great. We understand that this blockchain thing exists. The satellites are going to be the nodes, all the applications that you could think of for blockchain. The satellites are the nodes, but what is the space economy? Because you've been saying this word, but you haven't actually defined what is the space economy. And so the space economy in a nutshell, it's all the activities that lead us to space, in space, and of course the data that comes back down. So if you're taking notes, I want you to write 3 things down. Number one, actually 4 things. Number one, today in 2020, the space economy is worth approximately $400 billion. There's a little wiggle room in there. It might be a little more, it might be a little less, but it's worth $400 billion. To put that in context, what we think of as the AI, the artificial intelligence economy, in 4 years, or rather by 2026, the AI economy will be worth about $130 billion. So right now, the space economy is here. What we think about the AI economy is here. The space economy already exists. And of course, you're like, Samson, this is just so stupid. How could this space economy exist and we're just now hearing about it? Well, that's part of the reason the space economy allows me to be in Washington, D.C. and talking to people in Kerala, India. This transmission, again, those satellites in our orbit, that's part of the space economy. This communication, this recording on YouTube, this live communication, that's enabled by the space economy. Of course, it's like, oh, well, that's cool. We can talk. And so now half the world, or pretty much half the world who have access to the internet, they're on the internet. It's like, oh, okay. The internet actually runs through all these satellites, which is part of the space economy. So that's the first thing I want you to write down. The space economy today is worth approximately $400 billion. The second thing I want you to write down is that by 2030, the space economy will be worth approximately $2 to $3 trillion. This is in US dollars. There's a big range. Like, how can you have a range of $1 trillion that by 2030, the space economy is either going to be worth $2 trillion or $3 trillion? There's a lot of wiggle room in this because over the next decade, there's going to be so many advances in just the technology that we use in space. Recently, on December 10th, I want to say, China landed, rather, the probe China sent to the moon landed back in Inner Mongolia. And this was the first time in 40 years that anyone brought back samples of rocks from the moon. China landed on the dark side of the moon in a young impact crater. And so young in the sense of it's like 1 billion years old versus when America went to the moon, we landed in a crater that's like 3 to 4 billion years old. And the reason this is important is because when you have these rockets land and take samples and then return home, we can actually we have better understanding of what happened between 1 billion and 3 to 4 billion years ago in our galaxy. This is what this information, the samples that China has recently brought back. This is important because, again, that is part of the space economy. And write this down. When you solve for space, you solve for Earth. I'm going to give you a moment to write that down. I'll say it again. When you solve for space, you solve for Earth. The first thing this lets us know is that China has the capacity to send an unmanned robot to the moon. That's awesome. Not only can we send an unmanned robot to the moon, it can also return samples back to the Earth. And again, each of these steps is just breakthrough. The next thing is, how does China share that data? And so this is where we talk about an international consortium of scientists who say, hey, this is the first samples that we've gotten back in 40 years. This is amazing. And so all of this is feeding into the space economy. It's building up into the space economy, because when you solve for space, you solve for Earth. Got to remember that. So the other thing I want you to write down, because initially I said 4 things, but we're really going to talk about 5 things. So we talked about, we want to give you a simple diagram. If you draw a little triangle, we're going to write a simple diagram to talk about the space economy. And again, I told you, I struggle with telling the story. I get very excited about it, and I have to do a better job of delivering it. So when we talk about the space economy, we're talking about upstream. That's the first thing, right? Launch. Rockets are going up. That's awesome. That's super sexy. People are like, oh, rockets, Elon Musk, he's all excited. SpaceX, the commercial crew. India sent a rocket to the moon in like November, December 2019. And so even though that rocket crashed, it was still a success because India developed the technology. They have the smart people. They said, we're going to go to the moon. We're going to try it. We're going to be part of the spacefaring nations. That's a big deal. That's upstream stuff. All rocket launches, that involves upstream stuff. That's super sexy. It gets a whole lot of attention. Unfortunately, at the end of the day, rocket launches, you guys are like Ubers. You take stuff to space, right? You're a driver. It's like, okay, instead of getting in a taxi, you get in a rocket to go to work. And so it's like, oh, is there much money in rocket launches? Actually, not that much money, but it is super sexy and very exciting because after all, it's a controlled explosion. So that's upstream stuff. All of the industry that takes to launch rockets into orbit or outer space. And so there's lots of industries that go to, lots of technologists who build the rockets. You got to build the rockets. There's so much software that goes into navigating the rockets. There's the mission controls on the ground that actually control the rockets. And not only rockets, but also life support systems for when we put humans in these rockets and robots. There's other teams who actually man the robots because the rockets separate. This part now is reusable. This other part goes to wherever it goes. It takes a payload, and in that payload, you have different experiments. It's all part of the space economy, right? It's like rockets upstream. That's number 1 part of the space economy. Number 2 part is, okay, now that you've launched this rocket, that's in-stream. So you can write that down, in-stream. It's in-stream means you're in orbit, your rocket's in orbit. What is your rocket doing? Because now it's not the rocket, it's now a satellite, right? Now it's a satellite. Your satellite is doing something in orbit. What is it doing? The International Space Station, the ISS, it has been in orbit 20 years as of November 2020. And what this means, as the ISS has been in orbit for 20 years, also shout out to astronaut Victor Glover. He's the first Black astronaut to set foot on the International Space Station. He'll be there for 6 months on a research project along with the other folks from Japan, an astronaut from Japan, and 2 other Americans. So the International Space Station has been in orbit for 20 years, and it's proved that humans like myself and you and your grandkids, we can live in orbit for 20 years because there's been a person on the International Space Station for the last 20 years. And so in this instance, the ISS is like a hotel, but it's also a hotel and a research facility. This is the in-stream revenue of the in-stream business of the space economy. So it's not only the ISS, it's all the other satellites. If you've got one of these handy dandy devices called a mobile phone, a satellite helps you communicate. So that's just one instance. If you've ever gone to check the weather, you go to weather.com or you see a typhoon, all of that information that comes from satellites in orbit, from the in-stream stuff. So again, upstream rockets, they take your business to your business location. Once you get to that business location, that's where the in-stream stuff, what business are you doing in orbit? Whether you're in orbit, whether you're heading off to Mars, in October of 2020, the United Arab Emirates / Abu Dhabi, Dubai, partnered with the Japanese Space Agency and some American Space Agency to send a probe to Mars to monitor weather and to figure out how is the UAE, Dubai, going to send additional resources to Mars, additional exploration. So part of that is launch upstream, part of that is in-stream. Now that you're actually doing the business up there, what business are you doing in orbit or as you head to Mars? And then out of all of that, write this down. This is the most important part because this is where you all are going to make just so much money. Because space is the only place where you can have a quadrillionaire, and not a millionaire, not a billionaire, but a quadrillionaire. We might have skipped a couple of things, but a $250,000,000,000, meaning you are 10 times richer than Jeff Bezos. You have a $250,000,000,000. And how that happens is, first, you got upstream, launch. Then you got 2, instream. Your satellite is doing some type of collecting business research. The third part where you get the quadrillionaires is data. Your satellites are beaming data back down to Earth. Data is the new gold. Data is the new oil. Data is what makes blockchain and the space economy so crucial, because you probably want to encrypt this data so that you can take it from your satellites and beam it down to Earth. Because remember, when you solve for space, you solve for Earth. So all of this information, all these satellites, right now there's about 2,500 different satellites in space. Some of the satellites are huge, right? They're the size of a bus. But now they have these nanosats that are about the size of a baseball, and they have some that are like the size of my thumbnail, right? They're very small. They're called nanosats. And so the size of satellites continues to shrink, and what they can do has gotten more powerful while the size has shrunk. So in the next decade, in 2030, Apple, Amazon, Facebook, Netflix, etc., Tata, they're all going to be sending additional satellites up, primarily for this device, because you can access the history of your world on your handheld device, on your smartphone. Most of us just use it for social media, Instagram, Twitter, etc. But you can actually access the history of your world. And when we move to digital ecosystems, you don't take cash or money into space. So when you hear about, part of it is blockchain, meaning the application, the easiest application of blockchain is cryptocurrency. So it's just like, as we move to digital currencies, to cryptocurrencies, where Alipay, WeChat, etc., Facebook, Libra Coin, they want you to be able to pay with their type of currency, whether it's Alipay, WeChat, or Libra. It's going to be done on this device. It's also why Facebook is launching satellites into orbit, because they don't care where you're at in the world. They want you to be able to use this thingamajiggy to execute your trade, your transaction, your commerce. And so when you get upstream rockets, in-stream satellites, downstream, all this data is coming down. What do you do with it? How do you monetize it? Right now, about 98% of data that originates in space is discarded, because we don't have clouds in space yet. We're working on it. And so we're going to open up whole new treasure troves of data. And it could be something as simple as weather data. Space has a lot of weather, as well as space. There's weather for space as well as weather for Earth. You might have heard about this little thing called global warming. Global warming causes a thing called climate change. Climate change causes a variety of things. And if you want, we can show how global warming causes climate change, which in turn facilitated the pandemic, not H1N1, the COVID-19 pandemic. They're all related. All of this climate data, all of this global warming data, it comes from satellites. We beam it down to Earth. If we're going to tackle global warming, if we're going to tackle climate change, all of that data, it starts in the space economy. We just never thought about it that way, because most people are like, what is the space economy? And so we have those 3 parts to the space economy: upstream, rockets; in-stream, satellites. Also, people repair these satellites. They have refueling that they're working on. This gentleman named Daniel Faber, he has a company called Orbit Fab. They're launching rockets to be gas stations in space, because right now when you launch rockets, they run out of fuel, and then they become hazards. And they're floating around, they hit other rockets, they create debris. It's a pain in the butt. So Orbit Fab, they're going to be gas stations in space. So when you launch a rocket, you can actually refuel it. So it's not just the one and done. You're seeing that in space. Space is going very sustainable, because SpaceX is saying we're going to launch rockets, and then we're going to reuse the booster. And then Orbit Fab says, once you launch a rocket, reuse the booster. Once you get your rocket in space, we're going to refuel it, extend the lifetime by a decade or so. Again, we got to be sustainable in space, because also in space, you either recycle or die. And I mean this in every sense of the word, because in space you recycle your pee so you can drink it, so you can water your plants, etc. So 3 things. Upstream, rockets, launches, big rockets, big, very exciting stuff, not that much money. In-stream, satellite services. SpaceX launched Starlink, and Starlink is actually the most valuable asset to the SpaceX portfolio. And Starlink provides Wi-Fi, that 5G everyone's ever heard about or is hearing about. They provide Wi-Fi to the globe. And so all that data that comes down, whether it's for commerce, travel, business, get on an airplane, if you have a GPS, a global positioning system in any of these devices, I've got 2 of them right here. I've got 3 of them right here. And then I've got a hotspot, and I feel like I'm missing a phone somewhere. So all of these things, billions of these things, relies on data from the space economy. The question is, which one of you is going to develop a business that helps monetize that data? Because at the end of the day, the most valuable thing that any business has is their data. So you got to really think about, how is blockchain, AI, whatever the buzzword, how are you going to monetize that? And this is where blockchain and the space economy comes together, because again, the satellites are nodes. Do you have a public blockchain or do you have a permission blockchain to manage that data? Then what do you do with it once it gets to the ground? Meaning, how do you make money out of it? More importantly, how do we address global warming and climate change? So that in a nutshell is the space economy. I should have started off, the space economy today in 2020 is worth $400 billion. By 2030, it's going to be worth around 2 to 3 trillion, which means a lot of entrepreneurs, a lot of startups. India is in a prime position. You have a lot of smart people, and probably only next to Lagos in Nigeria. Lagos should be like the first or second most populated city by 2040-ish. The next Elon Musk, the next Jeff Bezos, they're either coming out of India, I'm not saying Kerala, I'm thinking Chennai maybe, or they're coming out of Lagos, Nigeria. Just the odd say of the number of smart people who are thinking about the future, about these quote unquote unexplored areas of digital transformation. Because as the world moves to using this digital stuff, whether we're talking about money, currencies, assets, et cetera, and using blockchain to notate those records, again, whether it's land records, medical records, records of debt that we call money, or rather our orbits in space, it's all going digital. And in digital ecosystems, India and Nigeria, they're going to be the leaders in the 2030s and 40s, hands down. So I told you at the beginning, the hardest thing to do is communicate this, because I get so excited. I'm like, oh man, I want to tell everyone about blockchain and the space economy. Hopefully by now you've gotten like, oh yeah, Samson is on the right path. He's not too crazy. The next thing I want to tell you is that I should have started here. We should have gone back in time, put on our tinfoil hats, and time travel back to 1993, 2001. Because in that time period, I could have told you about the internet economy. So if it was 1993 or 2001, and I was going to tell you about the internet economy, you would have first asked me, what is the internet? Because right now, the internet is so ubiquitous, we don't actually acknowledge it. It's like, yeah, I've got all these devices that connect me to the World Wide Web. I don't even think about it. But at one point, the internet economy was so novel, I'd have to explain it to you. So if it was 2001, right after the dot-com bubble, Amazon was trading at maybe $3.15. And I told you, hey, in 19 years, this black guy from Houston, Texas, who's now in Washington, D.C., would be talking to these smart people in Kerala, India, about blockchain and the space economy on the internet via Zoom. You wouldn't have understood any of that. You'd have been like, I don't know what you're talking about. I don't know what the internet is. I don't know what blockchain is. I don't know what the space economy is. I don't know what Zoom is. Because in 2001, none of this stuff existed. And so in 2001, I'd have to really tell you about the internet economy, how you could buy almost anything off of the internet, and that how in the future, fast forward to 2020, you can buy anything you want off the internet. You can connect with people around the globe via the internet. That the only $1 trillion companies, the FANGs, Facebook, Microsoft, actually, that's not part of the thing, but Microsoft, Amazon, the only $1 trillion companies would be internet, would be based on the internet, they would generate their revenue really based on data. I would have to explain that to you if this was 2001. However, now the internet economy is so much part of the economy that I don't actually need to explain to you that there's this thing called the internet economy exists, right? It's just sort of taken for granted. It's like, yeah, Samson, who doesn't have one of these, right? And so this is where the space economy is going to make the internet economy look like a little tiny startup, because the space economy is so much bigger than the internet economy. Recently, Nokia, they used to make these really cool block phones where you play Snake and the phones were almost indestructible. They won I want to say it's a $3 billion contract with NASA to put 5G on the moon. You know, we have global positioning here on Earth. We need some type of that on the moon. Right now that it doesn't exist, Nokia is going to make that happen. And so it's like, wow, that's so crazy. And that's actually not even that interesting, because it's like, oh yeah, a telephone company is going to set up a 5G network on the moon. When I say those words, you're like, oh, okay, that's cool. When is 5G coming to my part of the world? That's literally your only question, because I don't need to explain to you microwave radio waves. I don't need to explain to you how Wi-Fi works. I just blanked out, how does Wi-Fi work? I typically know how it works, because it's like, oh yeah, it's Wi-Fi. What's the password? That's all you care about. So as we go into this new digital ecosystem where we have digitally native products, goods, and services, where everything is based off of one of these smartphones. I don't have my watch on me at the moment, but a smartwatch, an IoT device, an Internet of Things device are a wearable. Now we're talking about, oh, I get what Samson is saying, because all of this technology, it relies on the space economy to actually function, more importantly, scale. And so if someone ever asks you, what the hell is the space economy? Say, let me explain to you about the internet economy. Right now, the internet economy is, I don't know. I actually don't know the number of that. Let's say it's a couple of $1 trillion. It's probably 5 to 7 trillion. Fact check me on this. I'll look it up. How much is the internet economy right now? If you take Microsoft, Amazon, and Apple, that's $3 trillion, $3.5 trillion right there. So let's say the internet economy is worth 7 trillion, maybe. We'll have to get George to validate this, because he's the economist. I'm just an anthropologist. That's the internet economy. When we get into space, the space economy is going to be so much bigger, because in space, rare earth minerals aren't actually rare at all. So gold, lithium, things that make these batteries, things that Tesla uses to make batteries to fuel these things, those elements, they're not that rare in space. We've actually just got to be able to get to them. So NASA sent out a probe called OSIRIS-REx. This also happened in October of 2020. And they went and connected with this asteroid. There was this asteroid named Bennu. It was 200 million miles away, traveling at 62,000 miles per hour. I don't know what that is in kilometers. Let's say 100 kilometers per hour, 100,000 kilometers per hour, 62,000 miles per hour. And they landed a probe on it. Remember, 200 million miles away, traveling at 62,000 miles per hour relative speed. They landed a probe on it to collect a sample, and they're bringing that sample back. The sample doesn't actually get here until 2023, but it is 200 million miles away. So what this proved when NASA was able to land the OSIRIS-REx probe on asteroid Bennu is we can identify a target that's 200 million miles away, traveling at 62,000 miles per hour. We can identify it, we can track it, we can lock on a probe to take a sample. That is so much science. It is so amazing, because actually we just demonstrated that as a species, if we ever have an asteroid that's going to impact Earth, well, we have a way of, 1, identifying it's there, 2, tracking it, and 3, sending out a probe, not to blow it up. We're not going to blow it up. This isn't like Bruce Willis in Armageddon. We have actual physics. We're just going to probably attach a probe to it and nudge it gently into a new trajectory, so that by the time it travels those millions of miles, it misses us by, a couple of million miles. So, but what that really means is we have the capacity as a species to save ourselves. The dinosaurs didn't have that capacity. That's why a meteor came in, struck the earth, wiped them all out. We wiped out about 70% of life on the earth at the moment. But humans, we have that capacity, and it's all part of the space economy. So we can actually save our species, which, to our point, we don't know if there's any other intelligent life form in the galaxy, not the universe, just our galaxy, that can do that. But we're building that capacity, and that's coming out of the space economy. So that was my first bit of rant. I'm going to take a pause. If anyone has a question, by all means, please ask me your questions. I'm going to give a 5 count before I go into my next rant about the Artemis Accords and going back to the moon. No questions? I know I hit you with a lot of information. A question is going to come up. So there's these things called the Artemis Accords. And so the Artemis Accords is an update to the 1967 Outer Space Treaty. You may have never heard of either, because in 1967, I wasn't even alive, but I've read them. And so the Artemis Accords establish how America, and we have 7 other signatories to this, are going to have permanent human settlement on the moon. And so I use these words very carefully, because remember when we started this exercise, I told you to write down these 4 boxes: tech, economy, philosophy, and regulatory. The tech is easy. I teach everybody how to make a chess piece, right? Just because I teach you how to make this chess piece, we're going to call this a rook, doesn't mean you actually understand the game. Because the other part of this is, philosophically, what does that mean? Because just because we can make these blockchain-based applications, this blockchain-based technology, and particularly when we take blockchain and combine it with AI, should we do it? Because philosophically, it opens up a can of worms around accountability, transparency, create some level of accountability. We have to talk about ethics. So should we actually do it? And this is what the Artemis Accords does for the permanent human settlement of the moon. This is where the US is looking to send an astronaut, hashtag Watkins on the moon, Jessica Watkins. She's one of the 18 astronauts recently named to the Artemis program, the Artemis mission, who will be landing on the moon in 2024. Hopefully the first woman to walk on the moon will be a Black American woman, because for purposes of racial equity and justice in the space economy, we need to have a person of color be a woman who is a person of color be the first woman to walk on the moon. We'll get to that. And so the Artemis Accords, they update, what is our mission? When I say our, I mean America's and the world. We're going to start representing the world again. I know perhaps we haven't been doing a good job of representing the world, but we're going to get back to that. What is our purpose on the moon? Permanent human settlement. The reason I'm going to say these words again about permanent human settlement is because this is a philosophical box. If we colonize the moon, we take all of the legacy of colonization with us, and we don't want to do that. Allura asked, so can we expect a separate satellite for each enterprise in coming decades? Allura, absolutely we can, because part of the reason every business, some people will be in the launch business, some people will be in the satellite business, Allura. You might not actually want to launch your own satellite, and you might not actually want to build your own satellite. You might want to just ask Melwin if you can rent his. Or Melwin might have a data company, and Allura, instead of you launching your own satellite, you actually just need the data that Melwin has. And so you just say, hey, Melwin, can I get your data? In which case, boom, problem solved, because it's about your business. What are the future applications? Sonali asks, what are the future applications of blockchain plus AI in the space economy? What is the future applications for blockchain and AI on Earth? That's for in the space economy. The permanent human settlement of the moon and Mars. Elon Musk says we're going to have 1 million people on Mars by 2050. I think he's wrong. I think we're only going to have 20,000 max, because we got to build out infrastructure on Mars to support this. So while we have the technical capabilities, we don't have the capacity at the moment to accommodate 1 million people on Mars, but we could definitely do 20,000. But before we go to Mars, we're going to have probably 100,000 on the moon by 2040 as a launching pad to go into Mars and beyond. Because the moon is really just a training. It's a habitat. It's a training zone for deep space. You got to go to the moon to acclimate your body, to figure out what are the effects of microgravity on the human body. We've never actually had a baby born in space. We don't even know if we've even tried to conceive a baby in space. So there's a lot of like little nuanced things that we have to figure out. Little nuanced things like birth, conception and birth before humans can go seed the stars. So when you say what are the future applications of blockchain plus AI in the space economy, you don't get a smarter city than the International Space Station, than what we're going to build on the lunar surface, than what we're going to build on Mars. So if you take blockchain, AI, whatever solution you have on Earth, you're going to apply it to space. That's it. I don't care if you're like IBM's Hyperledger, where you're tracking leafy vegetables, because you got to grow everything in space in situ. So you, of course, you need to track that in case you have the same problems we have with leafy vegetables or here on Earth. I don't care if it's digital identities, because in space, I really need to find my little watch, because in space, you'll have this thing called a tapper. You put a tapper on your wrist, because when you're wearing a spacesuit, guess what? You tap on stuff or you use voice control. And so natural language processing, that's sort of like, we're just going to call that a component of AI, where you talk to your devices, your tapper, your suit, your environmental suit. All of the solutions that you're coming up with Earth for blockchain and AI, you're going to have applications in the space economy, either living on the moon or Mars or in orbit, or how are you using that AI application in blockchain to encrypt your records, AI to analyze the data, take that data and make that data into revenue. So those are your applications. Anything that you can come up with on Earth for blockchain plus AI will be blockchain plus AI in the space economy. Does that make sense? All right, I'm going to assume it makes sense. And again, feel free to ask me additional questions. This is an entirely new industry. Well, rather, let me rephrase. The space economy has been around since shortly after the World War II, when America stole some Nazi scientists, or rather relocated some Nazi scientists from Germany into Alabama to help us with our Saturn V rockets to get to the moon. So the space economy has been boiling ever since then. And from the space economy, NASA has all of their IP, their SBIR, Small Business Innovation Research and Small Business Innovation Technology grants, the Centennial Challenge Program. These are from NASA that give grants between a couple $100,000, a few $1 million for businesses that have space applications. Allure just asked, maybe satellite service will be rented in coming years like a cloud providers presently. Yes, Allure. Exactly that. You don't need to own your satellite. You don't actually need to own the cow to get the milk. And so I use this example of not owning the cow to get the milk, because if you just need data from space, ask Melvin for it. Why do you need to have your own satellite? You don't actually need to own the internet to have an internet-based business. So like Comcast, Verizon, AOL, those are internet businesses. Amazon, Apple, Netflix, those are not internet businesses. They use the internet to make goo gobs of money. Oh yeah, I should have probably told you this. Spoiler alert. In space, blockchain is boring. Blockchain is HTML. No one cares. Blockchain is just like, yeah, it's infrastructure. It's plumbing. If you're a blockchain expert, it's like, oh, you're a plumber because you're in charge of infrastructure. No one cares. It's like whoever runs your website. Oh, you know, HTML, C++, Java, React. I don't care. I've got like 2,000 people I could call on in Reddit, and they could do the same thing. And that's the beauty of blockchain when we talk about blockchain in the space economy. It's actually very boring in space because everything is encrypted. Everything runs on blockchain networks because the satellites are the nodes, in which case it is really just plumbing. And so if you have aspirations of being a star space plumber, you can become a blockchain expert in space. And that's like, oh, when you're not making chess pieces, you're maintaining our network infrastructure. It's actually not that sexy of a job. And so, yes, to your point in your question, will each enterprise have separate satellites? Yes, much like cloud computing works. Some people will build their own satellites, much like some people build their own data centers. Other people will be like, I just want to rent space on your satellite, or rent space in your data center. And then other people will be like, I don't want to do either. Just give me the data product that I need on a subscription service, sort of like Bloomberg, right? So Bloomberg has these terminals, you access them, and you're privy to all this data. So other people will be like, yeah, we created the Bloomberg terminal for space, and that'll be a component of blockchain for encryption purposes, and then AI for whatever kind of analytics you're trying to do. So it's super important that as we contemplate going to space, to come back full circle through Artemis Accords, through how we're going to have permanent human settlement on space, because if we go to the moon and we colonize the moon, we end up with the current quagmire, political anxiety, social angst that we have on Earth. I don't know if you've been watching the news here in America. We've been trying to address our racial discrimination, our institutional bias, our prejudice that we have in America since, I don't know, 1619, when the first Black folks were enslaved in America. And so if we take those legacies of slavery, those legacies of colonization into the moon, into Mars and beyond, we actually don't advance very much as a species. Yeah, we're Homo sapiens. We have really cool tech. We can launch stuff. We can put stuff in satellite. We can put satellites in orbit. We can send down data. We can have quadrillionaires. But as a species, we're sort of still just like assholes. You know, we've got some really cool toys, but we haven't learned how to communicate, how to work together, how to collaborate, how to get over our cultural, religious, and ethnic isms to actualize that, oh, we're all humans. So this is why, on one hand, if we go to colonize space, someone's going to have to kill the masters. And you don't want to have riots in space. It's a really bad idea to have a riot in space, because you're in microgravity and whoever turns off the air first wins. And so this is why I wrote a book called Race in Space, Racial Equity and Justice in the Space Economy, because now you're like, oh, the internet economy, that exists. The space economy, it's going to make the internet economy look tiny compared to the space economy. We should probably address some of the social issues and challenges with the space economy now, before we start sending people to space to replicate the same systems of inequity and injustice that we face here on Earth. And we can list those to the ends of the world. They all exist. And so this is where we're talking about Artemis Accords, when we're talking about the fifth industrial revolution, which is the digitalization of data, the creation of digitally native goods, products, and services, that we don't create this giant gap between the haves and the have-nots. Because even now, roughly half the world in 2020, roughly only half the world still has internet connection, right? That's a huge digital divide. It's like this big of a digital divide. And so as we talk about the space economy, it's how do we make it more just? How do we make it more equitable? Because the solutions we're solving for space, they're going to be applicable for Earth. Because when we say what blockchain plus AI will we have in space, everything on Earth that we have for blockchain AI, we're going to have in space. The difference is Jeff Bezos, he's worth like 167 billion dollars. He's going to be this big compared to the first quadrillionaire in space. The first quadrillionaire in space is probably going to be Indian or from Nigerian. Why? Because by 2050, the race is on, the space race is on, and that's just how the odds say it's going to play out. And we need some kind of equity. Not that Indians or Nigerians don't deserve to be the richest person in the known galaxy, but we need some kind of equity between the haves and the have-nots, because when we solve for space, we solve for Earth. I think we're coming up on time. If you have any more questions, by all means, ask me. We have an agency in America called Space Force. It's actually not a vanity project from the POTUS 45, the Trump administration. Space Force will play a critical role in helping, I hate to call it space doctrine because it sounds so wrong, rather that has a military concept to it, about Space Force in the sharing of space, particularly around low Earth orbit, because right now the orbits, we don't have a air traffic control. So you go to the airport, there's an air traffic controller that says, hey, this airplane's landing, this airplane's taking off. Right now, we don't have an air traffic control for all the satellites, which means satellites in space, as we launch stuff, we don't want them to collide, have debris. Debris management will be a huge lift for AI because it needs to target track all of the, I don't know, it's about, I want to say 30,000 pieces of debris. And then the debris could be something really small. We're talking about something this big, right? And the fact that it's only this big, 3 or 4 centimeters, isn't it? In space, it's traveling around 16 to 17,000 miles per hour. The kinetic energy of when this little object hits anything else, E equals MC boom. The kinetic energy of this small object hitting something else, it destroys that object, it damages that object, it creates a slew of problems for the operations of satellites and, of course, safety of humans. So Space Force, they're going to lead a role in figuring out, hey, what is the air traffic control? They're also going to lead a role in diversity and inclusion in space because we need women. If you want to have permanent human settlement of the moon and Mars, you need at least 51% of the population to be female. You need this for a very simple reason, because you actually want to have kids born on the moon and Mars. Yes, there's lots of medical things that we have to figure out how to actually make that happen, because we don't know how that works in microgravity, but we're going to figure that out shortly. If there's anyone, lawyers on watching this, you want to be all over blockchain and the space economy, all over the space economy as a whole, because the question is, let me see who asked this question. If Sonali is saying, or Allura is saying, hey, I have this business, we're doing business on the moon, we're doing business in low orbit, well, whose domain, whose court do you go to if Allura's satellite is damaged by Sonali's satellite? I don't know, it's in space. Well, then, like, where are you based? On Earth. So then they figure out which jurisdiction to pursue something as simple as an insurance claim. So when we talk about the space economy, we do want to acknowledge that blockchain will be the infrastructure. It will be the plumbing upon which all data runs in the space economy. But more importantly, we want to think from an IP and intellectual property perspective and a property law perspective and a real estate law, who owns what in space. And this is where the lawyers come in. But lawyers also play a huge role in just gaining this elusive thing called consensus. How will businesses, how will governments, how will people operate in space? So in the 1490s, when Columbus sailed from Spain to the Americas, right, the ocean was space. Today, 2020, the space economy, that's the ocean of old. We're having all these explorers get on their ships, and they're exploring space, low Earth orbit. They're going to the moon. They're going to Mars. They're figuring out, is there life on Uranus? We recently, also in 2020, we detected some compounds that typically are only given off by are off gas by living things. So it's like, oh, is there life on Uranus? But no one ever talked about it. But we're going to send the probe out there. It gets there in 2023-ish, I believe. And so as we head off into the ocean blue, which is the sky of 2020 in the space economy, the lawyers are going to play such a crucial role of little stuff like contracts, negotiations, consensus amongst nation states of who owns what, who's creating a permanent human settlement. Are we going to colonize the moon, which I think is a horrible word. We shouldn't call the people who go into space warriors, because you only send warriors to go to war. You don't send warriors to do research. Right now in America, Space Force wants to call their space people warriors. I'm for explorers. And then if you go to Mars, you're a Martian sentinel, meaning you're standing guard, you're doing research. There's so much other things. This is where words matter, coming full circle, because you got to know how to communicate. What is your intention? What is your mission, your vision, your values, and your dreams? So my dream for the space economy is that it be more fair, just, and equitable. So as we solve for space, we share those discoveries with folks here on Earth, and the globe benefits, particularly if we're saying, hey, there's an asteroid coming in to hit Earth, and we want to send something to just nudge it out of the way. Well, this is going to happen. Asteroids and meteors hit Earth meteors hit Earth on a semi-regular basis, but there might be a big one. Then it's like, if India is in the position to nudge this meteor, this asteroid, from hitting the Earth, well, then, yeah, we should support India in their endeavor. And you guys might want to give us a bill. When I say us, the rest of the globe, a bill. And it's like, well, yeah, India just saved humanity, Homo sapiens sapien. We should probably write them a check or give them something in return, just to say thank you. By the way, you guys have my thanks in advance. So we've gone through a lot of things. We're coming up on the hour. We talked about chess. Don't just learn how to make stuff. right? Think about the tech, the economics, the philosophy, and the regulatory perspective. We didn't talk about the regulatory perspective. We mentioned the role of lawyers when we talk about IP, when we talk about trademark, even real property in space. But also from a regulatory perspective, you got to work with the globe, particularly for launch, so you don't have hit other stuff. And then who owns what? We talked about the three parts of the space economy. We could get even further down into the details, but just briefly to summarize, we have upstream, which is launch. We have in-stream. Now your satellite is doing something in orbit, some manner of business. Then we have downstream, which is all the data. The real values in the data, by the way, people are going to make extra money on upstream as well as the in-stream, but the quadrillionaires, they all are data mongols, not data mongols, data moguls. Yeah, maybe that's the word. They all own data, right? Moguls, data moguls, they all own data. That's what they focus on. That's how they make their money. When I say money, I should also say that in space, no one takes cash into space. There's no paper. There's no paper in space. It's all digital. And that's why blockchain in the space economy, there will be the evolution of these things called PEETs. And PEET stands for periodic table of elements, stable coins. Because when we find these asteroids, right? When we find these meteors, when we find these meteors and we mine them, there's a meteor called Psyche 16. It's worth some quintillions of dollars. It has enough rare earth minerals that every person on Earth could be given $98 billion in today's money if we brought it back. And so we don't want to do that for a variety of reasons. We'll talk about that later. But as we're able to mine these different meteors, we will have PEETs, periodic table of element stable coins, which will be asset backed by whatever mineral, because they're not rare, whatever mineral or resource we take off these things. I don't like to talk too much about PEETs because people are like, oh, stable coins, I'm so excited, cryptocurrencies. I'm like, guys, calm down. Cryptocurrencies are the easiest application of blockchain technology. Cryptocurrencies are literally the porn of blockchain technology. When the internet first launched, porn was like half the streaming content, right? It's like, yeah, porn. But you could do so much more with the internet than just stream porn. And so with blockchain, yes, you can make cryptocurrencies. You can even make what you think are stable coins. But let's look beyond the sizzle and look at the function. So when I say blockchain in the space economy, in space, blockchain is infrastructure. It's a really great way of securing infrastructure. So we have 5 minutes left in our sessions. If anyone has any other questions, by all means, ask them, because we've talked about the Artemis Accords, how America and some key nations are going back to the moon to have permanent human settlement of the moon, because we do not want to colonize the moon, because here in America, we already have so many issues with race relations, with prejudice, with injustices, with inequities. We don't want to replicate that on the moon. So I don't know the specifics about India, but wherever you go, humans tend to have issues with other humans based upon race, religion, creed, culture. We don't want to actually take that. We don't want to take the British-India relationship to the moon. We don't want to colonize the moon, because if we colonize the moon, someone will have to kill the masters. The other thing we talked about is crowdfunding. We didn't talk about it, but I'm going to give you the next 4 minutes or 30 seconds about crowdfunding. Very simple. You can write this down. Customers have more money than VCs. VC stands for venture capitalists. So everyone who's trying to raise money, they always want a VC to invest in them, an angel. I don't even know why you would call them angels, because angels, they want 10,000x return. They're really predatory angels, by the way. We'll talk about that later. So your customers are your fans. They have more money than your VCs. The reason that customers have more money than your venture capitalists is, who do you think actually pays your VCs back? So when Sonali or Allura, when you go to raise money for your business to scale, tap into your customers, turn your customers into investors. Because you, Sonali, you don't pay back your VCs, your customers do. You go sell your good product and service to your customer, and they give you money for your good product or service. You give that money to VCs. Get rid of the VCs. This is a blockchain space. Let's get rid of the middleman. VCs are middlemen. Let's get rid of them. You're going to use crowdfunding, investment crowdfunding. Here in America, that's through underneath the Securities and Exchange Commission. They have something called Reg CF. And under Reg CF, you can raise up to $5 million US. And under Reg A Plus, you can raise up to $75 million. So when you engage your customers, your fans, your community, your network, your advocates to raise money for your business, these people become disciples. These people become your biggest fans. So they're going to love it. And so keep that in mind. Crowdfunding is the way of the future, because as we go digital on these devices, your ability to connect with your crowd, with your customers, with your fan is exponential, because they will see your good product or service. And on one hand, they're going to be like, I love your pen. I'm going to buy your pen. And you can ask them, hey, you just bought this pen or this satellite service. Do you also want to buy shares in our company? All on the same dashboard, all on the same menu. Why? Because when you go digital, you can actually offer people not only your good product or service that they love, but also the ability to buy or invest in that business. So that's where the future of crowdfunding is. And it's the digitalization, this whole digital transformation. Amazing things happen when you get rid of paper. You have straight through processing. You can actually bring in your big data, your AI, et cetera. And so it means as we head to space and the space economy for the fifth industrial revolution, it's going to be as pivotal as when in 1990s, in the early 2000s, we did this internet economy thing. And so right now, the internet economy is such a part of just life in general. I don't even need to explain it to you. And in 20 years from now, by 2040, no one's going to tell you about the space economy. No one's going to tell you about blockchain either. It's just infrastructure that makes business and life possible for everyone, much like HTML and C++. It's not going to be that sexy, but it's going to be hella useful. So that's it for the moment. If there's a question, please ask it. I love talking to you. Next time I'm either in Bombay or Chennai, I will make a point to come to Kerala. In the meantime, follow George Pullen. Follow myself, Samson Williams, on Instagram. If you just Google me, Samson Williams, you can see my name and follow me. And I love talking about blockchain and the space economy. So that's it for the moment. Hope you all have a wonderful, safe day. And I will see you all in the next orbit and hopefully on the moon soon enough in our lifetime. Bye-bye.